So 3 points, 3C, continued. We're going to look at perimeter and area. Perimeter means the distance around the edges. So this is the measurement of the outside lines. Generally, we don't have formulas for perimeter because you're just finding the sum or adding up the lines, right? But there are a couple of cases where having a formula will help you as you're working through problems. All right? So, area is the measure of the region enclosed by the boundaries. So in other words, we're not measuring the measure on the outside, we're measuring the space on the inside. And with perimeter is just as, when you're talking about measuring with perimeter, you're just using basic units of length. But when you're measuring area, you're measuring in square units because you have length and width. So you're going to have square units. Now, so we're going to talk about some different shapes, the most common shapes, but there will be some other shapes that we use. We're going to look at a rectangle. So you've seen rectangles before. We're going to look at the formula for the area. And for rectangles, there is a formula that you can use for the perimeter that will make the calculations much easier for you. For area of a rectangle is simply found by taking the length times the width. Sir?
3C, does that say cost?
Continued. Now, length times width. Now, when you're working with rectangles, area is simply found by length times the width. It does not matter which one you call the length or the width, because remember, when you're multiplying, the order doesn't matter. Okay? Traditionally, the longer side is the length and the width is the shorter side, but it literally makes no difference. Perimeter has two different forms, and the form that you use is going to be determined by the information that's given. All right? So perimeter can be found by taking 2 times the length plus 2 times the width, because they have 2 lengths that are the same, 2 widths are the same. Or a faster method for perimeter is 2 times the length plus the width. So if you add the length and the width together and multiply them by 2. The reason you have 2 different formulas for that is sometimes one of these will be the unknown, the length or the width, in which case you want them separate. You don't want them in a bracket because it makes solving the equation a little more difficult. Okay. All right. The next shape that we're going to look at is a shape called a parallelogram. A parallelogram looks a lot like a rectangle that's just been pushed over a little. So you have a flat base and a flat top, and then slanted sides. And for these, we need to talk about a measurement on the inside, which is the height. And that height is always measured straight up from the bottom. It doesn't really matter where you measure it, but it has to be straight up from the bottom and cannot hit one of the slanted sides. And then you have the base on the bottom. Now, with a parallelogram, the measurement on the top is exactly the same. So if they gave you that measurement, you would know that those are identical, and we'll talk a little bit about that. Do you have a question?
Oh, I was just going to ask, what's the difference between a parallelogram and a rhombus? They look the exact same. What's the difference?
There's not no difference if they're not. So don't worry about parallelogram. Parallelogram has different properties in that these sides are always exactly the same, and the angles are always the same. Now, area for these is simply found by taking that base and multiplying it times that height. Hold on a second. So you're simply going to multiply the base times the height. For the perimeter, you just take the sum of the sides. There is no specific formula for most things for perimeter. You're just adding up the sides. Next shape is a trapezium. And for a trapezium, what happens is both sides are slanting in toward each other. And again, we're still going to use a height measurement, which is measured from the base to the top. We're still going to need a base, but because we have those two slanted sides, it's going to cut off part of the value, so it's not exactly the same formula as a parallelogram, but they are very similar. In this case, you're going to have area equals 1/2 times A plus B times the height, where B is still the base, A is the length of that top line. Because they're not the same, we need to include both of those measures in our measurement. It's just the sum of the sides. And finally, we have a triangle. And for triangles, the area is 1/2 times the base times the height, where the height is always measured from the base to the furthest point. And for the perimeter, that's simply the sum of the sides again. Now, sometimes you're not going to be given enough information to be able to find the area of a triangle using that particular formula. You might not have the height measurement, but you may know the lengths of all the sides. So there's another rule that will allow you to find the area of a triangle without knowing the height measurement, if we know all the lengths of all the sides. And this formula will be given on your formula sheet, so you don't have to remember it, but you do have to remember when to use it. And this is called Heron's rule. Now, Heron's rule is used to find... So Heron's rule is used to find the area of a triangle when you know all three sides. The formula is not great. There's a lot of math to do. It's very easy to do. Your calculator can do all the work for you, but sometimes it's your only choice. So I guarantee you're going to be using it. And here is the formula. Area equals the square root of S times S minus A times S minus B times S minus C, where S is equal to A plus B plus C divided by 2. Where A, B, and C are the sides of the triangle. So again, you don't have to memorize the formula. The formula is going to be given to you on your formula sheet, but you do have to memorize when you need to use it, right? And you need to remember that anytime you're talking about a triangle, we always label the sides of a triangle A, B, and C. You're used to that from when we did the Pythagorean formula, right? Sir.
What's the S stand for?
S is just... Okay. So what we're going to do is we're going to just go to the book and we're going to look at a few of these. Again, you've done these over and over again, but Heron's rule might be a little bit new to you, so you're going to need to practice with some of those. So let's talk about your homework for this section. You're going to do 8, B, C, 9, A, B, E, number 10, number 12, and number 16. Now we'll get through as many of them together today as we can. And of course, I'm going to call on individuals to work as we go, telling me what to do. So keep your notes out and be prepared. Let's go ahead and go to the book.